The research agenda of our lab at Boston College is try to develop new materials for the next generation high-performance energy conversion and energy storage.
Professor Wang's research is extremely important because it's a new frontier of science. It's a frontier that has added a significant new dimension to the field of chemistry and science in general.
I grew up in rural China and witnessed what the development economy and increasing use of energy did to the environment. That motivated me to seek an approach that can enable the prosperity without paying the negative price to the environment. And that led me to study how to convert, store, and utilize a clean energy source such as solar energy.
Dunway is using renewable, if you will, earth-abundant materials to solve an important problem facing society, and that is energy. And he's using these materials in an innovative way in terms of designing technologies for renewable energy.
We examine what makes these problems difficult and rationally design material structures that can solve these problems. For instance, the material platform we study very unique. The NanoNet was created by us here at Boston College.
Here at Dunway's lab at Boston College, we're making next-generation lithium-air batteries using nanonets. These batteries operate on the principle of combining the lithium-ion battery with oxidation in air. Using the nanonets, this makes these batteries very, very cyclable and also very stable.
A nanonet is a two-dimensional structure, looks like a web, and it's a highly conductive material that's made of earth-abundant elements. It is unique because of its structure and its conductivity and its chemical properties.
As an undergraduate researcher, I'm working on improving the electrolyte. We're using a cathode system right now based upon the titanium disilicide nanonets that we have previously made in this lab. These next-generation batteries will have a huge impact in the world, mostly in the form of transportation, as they're lighter and more efficient than the current lithium-ion batteries used in electric vehicles.
As a biologist, Dunway's actually using photosynthesis, a process that's evolved over billions of years in order to harvest light to make energy.
Iron oxide, is commonly known as rust, has a very unique band gap. Its band gap around 2 electron volts is almost perfect to split water, producing hydrogen as a solar fuel. This is known as artificial photosynthesis.
The research I'm doing in Professor Dongwei Wang's lab is trying to use earth-abundant material, trying to capture the solar energy from the sunlight and convert it into the clean chemical fuel such as hydrogen, which can be easily transported, stored, and utilized later. And compared to the existing fossil energy, hydrogen is a super clean energy. So we don't have to generate the green gas carbon dioxide when we utilize it. In this way, it's totally environmentally benign. So in our study, we are trying to improve the performance of iron oxide, which can be used in our photosynthesis reaction.
Our research produces material that can significantly increase the efficiency of the process, making artificial photosynthesis economically practical approach to our energy crisis.
We don't really differentiate between undergraduate and graduate education. We think that part of the state-of-the-art graduate education is for our graduate students to learn how to educate undergraduates.
We provide research opportunities to undergraduate students by offering them hands-on research experiences. This hands-on experience helps demystify science, which encourages our youth to choose science and engineering as a career path.
I'm only a junior, but thanks to Boston College, I've already published 2 pieces of research. I don't think I could have had the same experiences I have here working at Dunway's lab at another university.
Dunway's research in renewable energy fits very well with our energy focus moving forward, and also fits perfectly within the mission of the university.
Boston College emphasizes social justice. One way of offering social justice to offer people low-cost energy so that you can enjoy the high living standard without paying a premium. We have created an environment for our researchers that is highly open and flexible, so that our researchers can take full advantage of their creativity in solving critical problems that our societies face.